Hello everyone, this is Venugopal. I'm your mentor for geography. As part of this session, we will discuss about classification of rocks. In our earlier sessions, we discussed about lithosphere. We also discussed about the internal composition of the earth. Now in this session, we will discuss about classification of rocks. Now, why should we classify rocks? Because we know that rocks occur in different areas on the earth, and they would be of different densities, different texture. Their internal composition would be varying based on the chemical composition, and they also would have different crystal structures. Some of them would have fine crystals, some of them would have larger crystals. And why do we need to understand all of this? Because we use rocks for economic activity, also for construction. Most importantly, rocks form the genesis for soils. So if I have to understand soils in a particular area, I need to understand the underlying rock strata. That makes it easy for me to understand the chemical composition of the soil also. That is why it is very important for us to understand the classification of rocks. Broadly, the rocks are classified into three major groups: igneous rocks, sedimentary rocks, and metamorphic rocks. I'll repeat, we have three major groups of rocks. One is igneous, second one is sedimentary, and the third one is metamorphic rocks. Now, what are igneous rocks? Igneous rocks are formed by the cooling of the molten magma. Cooling of molten magma and solidification. The cooling and solidification of magma leads to the formation of igneous rocks. So when I am saying it's magma, that means it's hot, it's a molten material, right? The temperatures are in thousands of degrees centigrade. If the temperatures are thousands of degrees centigrade, let's assume that it comes in contact with any fossils. What would happen? The fossils would be burnt up. So that means what? The igneous rocks are devoid of fossils. Most important point. The igneous rocks are devoid of fossils. If you get a question sometime in the exam which talks about where do we find fossils, and if one of the option is igneous rocks, we should very clearly say igneous rocks would not be having fossils, because it is made up of cooling and solidification of molten magma, right? They do not contain fossils. They are normally crystalline in structure. Okay? Igneous rocks are crystalline in structure. But again, what is the size of crystals? Larger crystals, finer crystals? That depends upon where the solidification, where the cooling happened, how fast they cooled, right? Again, if we have to understand the crystalline structure of igneous rocks, we need to understand the chemical composition of the material, right? The chemical composition of the material defines the crystalline structure of the rocks also, okay? But based on the internal composition, we broadly divide the rocks into acidic and basic character. If it is acidic, that means there is more content of silica, right? If it is basic, that means there is lesser proportions of silica but more proportions of magnesium, iron, and aluminium. If you can relate this to our oceanic crust and continental crust, there we are talking about continental crust being of granitic in nature, right? More of granitic in nature, and the oceanic crust being of more basaltic in nature, right? Again, everything depends upon the chemical composition, right? So if what we are saying here, acidic means it is containing more amounts of silica. An example is granite. That means granitic material is again lighter, right? Basic, we are saying that lesser content of silica but more content of iron, aluminium, and magnesium. If you can relate this to the internal composition of the earth, when we were discussing the static model, where we divided the earth into crust, mantle and core. Mantle was made up of magnesium, major content was magnesium, right? And core was made up of iron, that means it's of denser material, right? So basic means greater proportions of iron, aluminium, magnesium, hence more denser and more darker in color. Okay, earlier I was giving an example of oceanic crust. Oceanic crust is of basaltic in nature, right? Now why I am giving that example, you will understand eventually. Also, based on the percentage of silica, the rocks are further classified into felsic and mafic. Felsic, if the composition has greater than or equal to 55% of silica, then it is called as felsic. If the presence of silica is less than 45%, we call it mafic. Felsic and mafic. Felsic means examples, that is more content of silica. We have granite, rhyolite. Lesser content of silica, that is mafic. We are talking about gabbro and basalt. Again, we will look at these certain images of these materials, but again, you need to understand that we have felsic, acidic. We talked about acidic. We talked about basic. Again, we are also talking about felsic. We are talking about mafic. We also talked about granitic. We also talked about basaltic. We talked about density, this being lighter in density, this being more denser, right? Now, we were talking earlier about cooling and solidification of magma. Now, does cooling and solidification need to happen only when the magma is erupted into the outer earth? Not necessarily. It can be within also, right? So, if it is within, it is called, anything within the earth is called plutonic or intrusive, right? If it is ejected outwards, it is called as extrusive, right? So, intrusive igneous rocks, that means which are solidified, which are cooled and solidified inside the earth's crust, they are called as intrusive igneous rocks. Since they are within the earth's crust, they take larger time, they take more time to cool down. So if they are taking more time, that means they cool down slowly, they have more coarser grains when they are trying to solidify. The extrusive igneous rocks, since they are exposed to the elements of the nature, right, they cool down much faster and they are fine grained, means smaller grain structure, okay. This is an example of extrusive igneous rocks. Make a note of this. Why? Because there could be questions on which of these could be extrusive igneous rocks, which of these could be intrusive igneous rocks, something of that sort, right. You see pumic stone, this is an example. Rhyolite, earlier when we were discussing about acidic or felsic, we talked about rhyolite, granite, right. Again, basaltic, this is an example of mafic, that means lesser content of silica, right. Basalt is also an extrusive igneous rock. Intrusive igneous rock, we said they will have coarser grains. If you look at the images itself, you can understand that there are coarser grains in this, right. Example is granite, gabbro, right, diorite. Now, we discussed about acidic basic, we discussed about felsic mafic, we discussed about intrusive and extrusive. Now, this diagram tries to summarize all three into one picture. You see here, felsic means more content of silica, mafic means lesser content of silica, right. Intrusive, that is within the content, within the earth's crust, we have granite, gabbro, right. And extrusive, that means outside the earth's crust, we have rhyolite and we have basalt, Mafic crystallizes faster than felsic. So we are talking about solidification and cooling and solidification, right? So mafic crystallizes faster than felsic. Extrusive cool faster than intrusive. If the magma cools slowly underground, the product will be gabbro. If it cools quickly at the surface, then the product will be basalt. We just discussed about this, right? See here, mafic. If it cools within the earth, say, within the earth, that means intrusive, it is gabbro. If it is outside the earth's crust, it is basalt. Now, there could be some prelims questions on this topic. Consider the following statements. Granite is a result of intrusive volcanic activity. Yes. Granite is made up of finer crystals compared to basalt. Is that so? No. Why? Because when we were discussing, we said granite is intrusive, basalt is extrusive. Granite is intrusive, right? That means granite should have coarser crystals compared to basalt. Basalt should have finer crystals. That's why only the first statement is correct. Next question. Consider the following statements. Basalt has higher silica content, hence basic in nature. Is this true? No, right? Because we said granite has higher silica content. We called it acidic. We called basalt as basic nature because it has lower silica content. Again, lower silica means what? We also talked about mafic, right? We talked about felsic, mafic. If that's the case, basalt has higher silica content, hence basic in nature. This is wrong. Basalt is more denser than granite. Yes, because we were discussing about what are the contents of mafic. The rocks, they would have iron, nickel, magnesium, right? Silica is of lighter material. If there is lesser silica, it is basic. We said basalt has lesser silica, hence basalt is more denser than granite. This is a true statement. This is a false statement. Okay? Now, let's discuss about the second group of rocks, which are sedimentary rocks. Now, what are sedimentary rocks? Sedimentation means it is a process of where an agent, which could be a river, which could be wind, carries certain material, deposits in a particular location, and there is a continuous deposition for a certain period of time. If it continues for a larger period of time, the overlying materials increase the pressure, right? And if they increase the pressure, this sediment start crystallizing into a rock. That is called as a sedimentary rock. Formed from sediments accumulated over a period of time. Again, these are stratified rocks. Why am I saying these are stratified? Because now this material is being pulled up and deposited, right? This material is carried and deposited at a particular location. When it is being deposited, definitely there could be a sorting in that area. And when it is, where it is it being sourced from? Let's say if it is being sourced from a particular mountain, right? Whatever is the content of that mountain, the chemical composition of the material of that mountain would be the chemical composition of the content of the sediment. So if we have multiple sources and it is occurring periodically, right, one after the other, that means we can have sediments of different chemical composition in different layers. That means different strata. That's why we are calling it as stratified rocks, right? Non-crystalline. These are non-crystalline. Now earlier when we were discussing about igneous rocks, we talked that, or we talked about it not having any fossils. But with sedimentary rocks, they would be having fossils because they do not have any magma or something to burn up the fossils, right? That's why we will find fossils in sedimentary rocks. Now, there should be some classification within this sedimentary rocks also, right? So the sedimentary rocks are classified based on their origin and composition. Okay, based on origin and composition. Okay, now mechanically formed. Mechanically formed means we have deposition of sediments. When the sediments were continuously being deposited for a larger period of time, what would happen? There is a pressure, mechanical pressure being exerted by the topmost layers on the bottommost layers. Eventually this leads to the formation of a rock, right? This is called as mechanically formed. Next, organically formed. The source of the sediment being an organic material, skeletal material, shells of living organisms, etc. These all could be source of the sediments. That's when they are called as organically formed. Then chemically formed. Chemically formed means, let's say you have Dead Sea, right? What is the salt content of Dead Sea? It's pretty high. And if the water evaporates and deposits salts, that is a chemical process, right? So deposition of rock salts, etc. These are all chemically formed. Okay? Let's look at this image. Erosion of material, particles are carried, transportation of the eroded material. It could be any agent, it could be wind, it could be river, water, right? It could be any agent. The eroded material is being carried and getting deposited. You see different strata, that's why we are saying stratified rocks, right? You see different layers of different material, right? Deposition of particles deposited, right? Initially they are loosely packed. Then, because of the mechanical pressure being exerted, there is compaction of the material. That means there is squeezing, right? Compaction, particles squeezed together under greater pressure. Then cementation. Eventually they form a rock. This is another image which depicts different kinds of sedimentary rocks. Okay? If we have rocky material getting deposited, it forms a conglomerate. If we have sand getting deposited, it turns into sandstone. Clay and silt is deposited over a period of time, then we have shale. And if lime is getting deposited, we have limestone. This is one more example. Okay? Shale, coal, limestone, right? Coal is dark greyish black. We all know that, right? Coal is an organic sedimentary rock. This is very important. There could be a question if one of the options is coal and it says that which of the following is a sedimentary rock, then definitely we should not exclude coal. Coal is definitely a sedimentary rock. Okay? Similarly, limestone, we already discussed about it. Breccia is a fine grained, is having fine grained texture. Okay? Okay, now we will discuss about metamorphic rocks. What are metamorphic rocks? So, there is a rock, it has certain material composition, okay, but when this is being subjected to heat and pressure, its properties change, its properties evolve. Again, most importantly, when we talk about metamorphic rocks, we need to understand that because of excessive heat or pressure, they are not again converted into magma. We need to ensure that we need to be very clear about this point, that this excess heat and pressure will not convert this into magma, but there is a change, there is a transformation. All rocks may become metamorphic under heat and pressure. Change of geological texture or minerals in pre-existing rocks without melting into liquid magma. This is what I was trying to say. The metamorphic process doesn't include the conversion of a rock into magma again. It is just because of the heat and pressure, their properties are changed into something else. You see here, increasing temperature, increasing pressure. If the pressure is more, right, a slate becomes blue-sheshed. Again, if at all, there is increasing heat and relatively lesser pressure, right? See the transformation, right? A shale would become a slate. If there is further availability of heat, it becomes schist or niche, right? So that means in any of these transformations, we are not seeing the conversion of the original rock into magma, right? It is just transforming into something else because of heat and pressure. This is called as metamorphism. Now, can I say that all rocks can become metamorphic? Yes, obviously. Both sedimentary and igneous can become metamorphic rocks if they are subjected to heat and pressure. Clay becomes slate. The transformation, right? This is also important from the UPSC standpoint. If we are trying to understand the next stage of one of these rocks, whether it is igneous or sedimentary, we need to understand which will turn into what, right? Clay becomes slate. Limestone becomes marble. Economic importance because we are using marble in construction quite a bit. We also use limestone in construction quite a bit, right? Sandstone becomes quartzite. Sandstone becomes quartzite. Granite becomes niche. Shale becomes schist. And coal becomes graphite. So when there is heat and pressure, each of these rocks are transformed into something else, right? Now, we talk about heat and pressure, right? Generally, where can there be sources of this heat and pressure? Let's try to understand. When there is a divergence of plates, that means when two plates are moving apart, there could be volcanic activities, there can be magma oozing out. There is a source of heat, right? Also, when there is mountain building activity, right, there is a lot of pressure being applied. Also, there could be chance of magma moving upwards. In that cases also, we have chance of metamorphism. Again, you will understand these two when we discuss about tectonic plates, when we discuss about subduction of one plate under the other one, when we talk about sea floor spreading, which we will discuss in our next classes. But again, what I am trying to emphasize here is that these are the different scenarios where there can be the heat and pressure that can lead to metamorphism of the rocks. Now, we also need to understand rock cycle. This is another important concept. What is rock cycle? Rock cycle is nothing but, you see, we have rocks or landforms on the lithosphere. There could be rainfall, there could be wind erosion, right? Because of erosion, the material is transported and they are deposited. When they are deposited, they become sediments, right? The sedimentary rocks are compacted and cemented and they form sedimentary rock, right? And when they are buried and there is high pressure, high temperature, right? They could be converted into metamorphic rocks, right? Now, when they come in contact with magma, this metamorphic rock can melt, right? And it becomes magma, part of the magma. But when this magma oozes out as lava, this generates igneous rocks, whether it could be intrusive or whether it could be extrusive. Intrusive or extrusive, right? So this will form igneous rocks again. This will form the landforms again, which would further be again subjected to, eventually be subjected to weathering and erosion, again transported, again deposited, formation of sedimentary rocks because of compaction and cementation, again because of deposition over a period of time, there could be heat, there could be pressure, which will again transform it into metamorphic rock. Understood? So this is called as rock cycle. So there could be a UPSC question on this where they would ask about rock cycle. Then you should be able to link to the igneous rocks, metamorphic rocks, sedimentary rocks and draw a diagram like this. Picture speaks volumes. So you should be able to draw a diagram like this. Now let's discuss some prelims questions. Consider the following statement. Granite and basalt are examples of igneous rocks. Yes, they both are examples of igneous rock. Basalt is an extrusive igneous rocks. That means it's on the outside the earth, right? Granite is formed when there is an intrusive cooling and solidification. Gabbro is a metamorphic rock. Is it true? No. Gabbro is an intrusive basaltic rock. So, only first statement is correct. Now, if there could be a mains question, it is like classify sedimentary rocks based on composition and origin. So, if you have to discuss based on composition and origin, we did cover this, which is mechanically formed, organically formed, chemically formed, and we need to explain that with diagrams. When we say mechanically formed, we need to draw a diagram which was we need to draw this particular diagram where we will emphasize on deposition. First is erosion, transportation and deposition. Deposition, after deposition, multiple layers are deposited. So there is stratification of layers. Then we will have compaction because of pressure. Further, there will be cementification, right? That's how a sedimentary rock is formed, right? Then if possible, we should be able to draw this diagram also as to the source defines the kind of rock. Sand will lead to sandstone, clay will lead to shale and lime will lead to limestone. We should be able to explain that. Okay.